Thank you. Morning, everyone. I'm Xinliang Zhu. Today, I'm going to present on behalf of Zhenyu Yang from Institute of Automation, Chinese Academy of Sciences. He has the visa issue, which makes him not able to present here. The paper is titled LDRE, Large Language Model-based Divergent Reasoning and Ensemble for Zero-Shot Composed Image Retrieval. Let's first start from the brief overview of the development of image retrieval. It starts from the unimodal image retrieval, where both query and gallery are in images. Like given a cat image, find another image containing exact or similar cat to the query card. Later, there are a lot of applications and methods regarding cross-model retrieval, where the query and gallery are in different modalities, like text and image. In this task, people might type a cute cat, and the system needs to find the image of a cute cat. Recently, multimodal image retrieval gets more attention, where the query contains both image and text. In this example, the user not only provides a cat image, but also an additional reformulation text turned into line. It's expected that the system understands the combined search intention and returns corresponding image from the gallery. As access shown here, the methods behind the system vary from straightforward to more complicated. Before we dive into the details of our research, let me briefly introduce the background of our research. Similar to multimodal image retrieval, before we propose an LLM-based divergent compositional reasoning to generate diverse edited captions covering possible semantics of the composed results for further retrieval. To conduct the divergent compositional reasoning, we generate dense captions for the reference image with focuses on different semantic perspectives. Then, we prompt a large language model to infer divergent edited captions based on the modification text describing possible composed images of diverse semantics. For the second challenge, we propose a divergent caption ensemble to integrate complementary information in divergent edited captions and fill out noise. We computed the semantic relevance score for every edited caption to measure the relatively reduced similarity encoded by the semantic addition toward the images in the database. The semantic relevance scores can be regarded as the distinguishing scores of every edited caption, weighted by which an ensemble caption feature is obtained by clip. Finally, the composed image can be retrieved based on the cosine similarity in the clip feature space. We compare our method with SODA baselines on 3 public datasets, Circle CIR and Fashion IQ, which have been widely used for CIR. On Circle, given that each query has multiple target images serving as ground truth, we utilize mean average precision, a more fine-grained metric to take into account the rank of retrieval results. On CIR and Fashion IQ, following the original benchmarks, we use required K as the main metric, which denotes the percentage of target images being included in the top K list. In this figure, we present qualitative results for composed image retrieval, which we conduct on the test set of Circle. The results demonstrate the effectiveness of our proposed method in successfully retrieving the target image. For instance, as shown in the first column here, the model must be able to maintain the semantic category of the bicycle in the reference image, and then place it in the water in order to retrieve the target image. We carefully select a variety of representative retrieval pairs that demonstrate the adaptability of our method and different editing conditions. Those modifications encompass various semantic elements such as zoom, color, background count, and content. This variety allows us to showcase the ability of our LDRE to adapt the changes in modification text from different perspectives, thereby highlighting its robustness. So here we show the quantitative results. The table contains a lot of numbers. So to summarize, our methods beat all the baselines with 3 different backbones on different tasks and different datasets. And also it beats the unimodal like image-only or text-only query by a large margin. To summarize, it's improved by 16.85% over the current SOTA on MAP at 10. We also conducted ablation studies on the proposed methods on SIGIR and Fashion IQ benchmark. Sorry, I read the second slide. Extensive experiments conducted on SIGIR and Fashion IQ benchmark datasets also demonstrate significant performance improvements of the proposed LDRE compared with the SOTA methods for zero-shot SIGIR. So we also conducted ablation studies on the circle dataset for the 4 major components in this method. So the result shows those components are necessary for our design. Now let's take a moment to discuss hyperparameter analysis. Through our experimentation, it's become clear that the model can achieve a fair performance with an approximate value of n between 13 and 16, taking into account the trade-offs in terms of computational cost and effect. From this figure, we can observe that model can achieve the best performance when the tau value is set to 0.04. Since our proposed method heavily relies on VLMs for retrieval and large language models for reasoning, we studied several VLMs and large language models to understand the effect they have on the final performance. So to summarize, our design is plug-and-play design, and it's training-free. It gives us the freedom to consider the trade-offs between computational cost and effectiveness. And our code is available on pip on the GitHub. And from the pip with code, it's improved by 16.85 over the current SOTA. And welcome to follow our work. Thanks. Questions?